Hello. So in this part, we will learn about these three topics. First is motion in a straight line. Second, motion with constant acceleration. And third, motion under gravity. So actually, all this corresponds to motion in a straight line. So when we have a situation where motion is happening in a straight line, so what we do is, actually it becomes fairly simple then. So we consider this line as our axis. Okay, so let's say this becomes my x-axis and I take a suitable origin. Okay, so origin is generally, we start the time from there, so t equal to 0 is the origin. And then we consider the motion of the particle in this line. So as you can see, the x coordinate on this axis gives me the position of the particle. Okay, so the displacement is given by the x coordinate, and the velocity then becomes dx by dt. Okay, so the rate of change of x with respect to time gives me the velocity, and also the acceleration is given by dv by dt, rate of change of velocity, or d by dt of dx by dt. So this becomes d square x by dt square. So double differentiation of x gives me the acceleration of the particle. Okay, so if, let's say, the acceleration and velocity, they have the same direction, so the velocity increases with time. Okay, and if the velocity and accelerations are opposite to each other, then we can say that the velocity decreases with time. Okay, so that means the particle deaccelerates. So deacceleration means negative acceleration. Motion with constant acceleration, this also becomes fairly simple. So we know that we have v dv by dt is equal to acceleration a. Okay, so if acceleration is constant, I can say dv is equal to a dt, and if I integrate this, let's say from u to v, so let's say the initial velocity is u, final velocity is v, and time is 0 to t, then that becomes v minus u is equal to at. Okay, so this is my first equation of motion under constant acceleration. Okay, so this means I can say v is equal to u plus at. Now this v is nothing but dx by dt is equal to u plus at. Okay, or dx is equal to u plus at dt. Now I integrate this, so x goes from 0, so let's say I start at x equal to 0 and t equal to 0 is my origin. So dt goes from 0 to time t. So this becomes x is equal to ut plus half a t square. So this is my second equation of motion under constant acceleration. So let's say from equation 1 I can say v square is equal to u plus at whole square. So this gives me u square plus a square t square plus 2u a t. So this gives me u square plus 2 a. So this gives me u t plus half a t square. So this gives me u square plus 2 a, ut plus half a t square is x. So this gives me the third equation of motion. So these three equations of motion we need to understand are only valid when acceleration is constant. Okay. So now let us try to study the motion under gravity, which is also an instance of motion in straight line. So when any object is dropped near to the Earth's surface and when we assume there is no air resistance, we consider this motion of a freely falling body as a motion in straight line. Okay, so in these cases, we have to fix our coordinate systems in such a way that y-axis actually becomes the axis along which the motion happens. And sometimes we might have to take up direction as positive y, and sometimes we have to take down direction as positive y. Of course, we know that acceleration due to gravity will always be acting downwards. So this acceleration due to gravity is g, and its value is 9.8 meter per second square, and which is always constant. Okay, so now let us try to understand this by way of an example. So let us say that there is, a ball is thrown up with a velocity u. Okay, so we need to find out what will be the height that it will go to. Okay, so we will draw a diagram of this problem. So what will be the height? So the only thing we are given is this velocity u. Okay, so now in this problem, how will I go about it? Let's say I consider this as my y-axis. Positive y is up. Okay, or the direction of initial velocity is towards positive y. Now we know that acceleration is acting down. Okay, so how will we do this? So we need to find out what will be the distance that this one travels, and I have initial velocity, and finally I know the velocity will be 0. So as it goes up, the body deaccelerates under gravity. Okay, because gravity is acting on opposite direction. So finally it will have velocity 0. So if I use the third equation of motion, this becomes v square is equal to u square plus 2ax. So now when I apply this in this situation and under my frame of reference, where I have considered this to be origin and this to be positive, I say final velocity is 0, initial velocity is u square positive plus 2a. Acceleration is towards negative, so this will be minus g, and x is towards positive, so x is positive h. So this gives me h is equal to u square by 2g. So that's how we need to define our coordinate system, and it's very important to use correct sign convention here. Okay, since displacement, velocity, acceleration are all vector quantities.